Good morning. Welcome to our 7th webinar on waste to energy as an integral part of Egypt's integrated sustainable energy and waste management strategy. Ladies and gentlemen, my name is Hafs Salmawi. I'm professor of energy engineering at the Gazi University in Egypt and key expert in the project support to the technical and financial sustainability of renewable energy and energy efficiency sector, as you see behind me. The project is executed by a consortium of consultants. The project is an EU-supported project to the energy sector in Egypt. The project is executed by a consortium of consultants led by DAI Human Dynamics, including, in addition to Human Dynamics, Tractable, NG, and Lamar International. The project consists of 5 components for reorganization of 4 functions of the new and renewable energy authority in Egypt, modernization of renewable energy framework, establishment of an energy modeling unit for the update of the energy strategy of Egypt, establishment of the Cairo Sustainable Energy Information Center, and last but not least, for sure, technical assistance to the energy efficiency and climate unit at the Ministry of Petroleum and Mineral Resources. It's my pleasure to invite Dr. Mohammed Musa Omran, the Executive Chairman of Egypt ERA, to deliver his welcome speech. Dr. Musa. Dr. Musa is on. Please unmute your microphone, Dr. Musa.
Good morning, colleagues, distinguished participants. I wish to begin by thanking the EU organizers for inviting Egypt ERA to take part in this webinar to elaborate more about the energy strategy and in particular the waste to energy as an integral part of Egypt's integrated sustainable energy and waste management strategy. It's indeed a good opportunity to be with you with this high level of expertise deliberating on this matter. According to Egypt Energy Strategy 2035, electricity sector intended to increase the supply of electricity generated from renewable energy to be 42% by 2035, and we have intention to increase it in the update of this strategy to reach more than 60%. Energy strategy ensured integrated sustainable, social, economical, and environmental dimensions, and as we work to obtain SDG 7. Successfully, legalization and the policies for renewable energy was interpreted by Egypt ERA to feed-in tariff regulatory framework, where Pimpan Solar Park is a power complex of 41 solar power plants has been developed in Pimpan. As for small and medium renewable energy projects, Egypt ERA issued several circulars for incentivizing net metering projects. Currently, energy strategy is revisited since its dynamic strategy. New technology as addressed waste to energy, especially generation, was announced. The Egyptian cabinet in 2019 set a feed-in tariff for waste to energy projects as a step to encourage investment in this sector, where Egypt ERA played a vital role in designing this feed-in tariff. Egypt ERA shall collaborate with all stakeholders to finalize waste to energy regulatory framework, particularly with Waste Management Regulatory Agency on several aspects illustrated on the Prime Minister Declaration as follows. Interconnection contract between the waste to energy plan and the electricity distribution company. Contract between the electricity distribution company and the relevant governorate, where the electricity distribution company will pay the governorate for the received electricity. Power purchase agreement between the relevant governorate and the developer of the waste-to-energy plant for the supplied electricity. Technical codes for waste-to-energy project connection to distribution companies. Colleagues, your inputs today will enlighten Egyptera for its future work to have solid regulatory framework for waste-to-energy. Thank you, and I wish you all a fruitful webinar. Thank you.
Thank you very much, Dr. Musa, for the welcome speech, and which emphasized the role of the Egyptian Electricity Regulatory Agency jointly with the Waste Management Regulatory Agency in leading this program and enable the success for this program. Ladies and gentlemen, according to the Integrated and Sustainable Energy Strategy of Egypt 2035, Egypt possesses an estimated total biomass potential in the order of 60 million tons per year. This is mainly composed of agricultural residues, like crops residues such as rice straw, animal byproducts like cow dung, agro-industrial byproducts such as rice husk and bagasse, exotic plants like wardenil and reeds, oil crops like rapeseed, jatropha, castor oil, etc. Other crops such as elephant grass, municipal waste, which includes municipal waste, solid waste, mixed with non-organic waste, and sewage sludge. So we have, as you see, a variety of a different characteristic, different properties, different sources, which makes this sector not an easy to tackle, and I couldn't say complicated, but it needs a special treatment. Recent estimate of the energy strategy of Egypt 2035 showed that the potential biomass available for electricity production could reach 62 terawatt hour. The evaluation is underestimated due to part of biomass still not monitored, especially the organic residues of agro-industrial sector. The aforementioned estimate is based on the possible processing of waste to produce 5 million tons of biopellets, briquetting, driving by lignocellulosic chain, and 3.5 billion normal cubic meter per year of biomethane derived from biogas chain. In this context, integration of biomass sector to the national energy policy will contribute to accelerate the transition towards energy security, the green economy, and carbon neutrality. On the other hand, electricity generated from biomass in general and waste in specific has its merit as a source of dispatchable renewable energy to partially balance other intermittent renewable energy supply sources, as well as improve the system inertia, which can ensure system stability. Considering the importance of properly managed the sector for solid waste, the government of Egypt established a regulatory agency for solid waste management as a step towards the better utilization of the solid waste. Regarding municipalities' waste, which represents a serious environmental problem, the government of Egypt has set 3 objectives, including increase the collection system efficiency of the municipality solid waste from the origin, residuals, and commercial units, residential and commercial units, increase the treatment rate for municipality solid waste through mechanical biological treatment, MBT, and thermal treatment for energy conversion waste to energy. The third one include reduction of the final disposed solid waste to the sanitary landfill. So the outcome of the first two steps will help in reducing these volumes for disposal. Accordingly, the Prime Minister issued a decree, as Dr. Musa pointed out, which is called Decree 41 for the year 2019, which establishes a system for a feed-in tariff for electricity generated from municipalities' waste and sludge. The decree set the rate and contractual relationship among stakeholders. The project support to the technical and financial sustainability of renewable energy and energy efficiency sector has developed a report on waste to energy focusing on the business model and feed-in tariff scheme for electricity generation by biomass waste. It includes, in addition to the techno-economical assessment of the feed-in tariff program on a waste to energy, the minimum requirements of contracts among the different stakeholders, and a roadmap for the program implementation. In our today's webinar, we will learn more about the status of waste to energy program in one of the leading countries in Europe, which will be delivered by Dr. Vito Piantelli, Head of Biomass and Biotechnology for Energy and Industries in Industries Lab, ENA, at the Italian Agency for New Technologies, Energy and Sustainable Economic Development. Also, Dr. Carla De Corollis, bio-waste expert of our project, and she was responsible to develop our project on biomass report, will provide a presentation on feed-in tariff role of the waste management process and socio-economic benefits. We're supposed to have Dr. Khalid Al-Farra with us. Unfortunately, Dr. Khalid Al-Farra lost one of his relevant, and we pray God to bless the soul of the died person. And unfortunately, he will not join us, although Dr. Farra was a key person in developing the feed-in tariff program and developing the strategy and planning for the waste to energy program. The point of view of developers will be presented by one of the highly knowledgeable and pioneer developers in this field in Egypt, Dr. Hatem Al-Gamal, will provide the perspectives of the private sector on the opportunities and challenges of the waste to energy program in Egypt. We will have the presentation by our presenters, which will be followed by Q&A session after the presentations. I encourage all our attendees to forward their questions using the chat tab at the bottom of your screen. Our first presenter presentation will be provided by, as I mentioned, Dr. Vito Piantelli, and Dr. Piantelli graduated in chemistry, has worked at ENA, the Italian National Agency for New Technologies and Energy, Sustainable Economic Development in biomass and bioenergy field since 1983. And I appreciate if some of our participants mute their microphone because we have some interferences. Dr. Piantelli works for Biomass and Bioenergy 1983 and is at the present the head of the Biomass and Biotechnology for Energy Laboratory in the Energy Technology Department. Dr. Piantelli has been and is at present responsible for a broad range of RDD, research and development and demonstration activities, including project management and supervision on biofuels and bioenergy production and utilization, energy groups, industrial utilization of agricultural raw materials, and technological innovation of agro-food and agro-industrial systems, as well as for research programs, review and evaluation on behalf of the national and international organization, including the Italian Ministry of Education, University and Scientific Research, and European Commission. Since 1999, Dr. Piantelli is a member of Italy of Executive Committee of the IEA, International Energy Agency, Bioenergy Top Technology Collaboration Program. And since 2009, he is a chairman of ITA-BIA, Italian Biomass Association. Dr. Piantelli, the floor is yours. Please go ahead.
Okay. Thank you, Professor.
Yes,
thank you, Professor, for introducing me, and good morning, everyone. Can you look at the presentation?
Yes, yes, it's
okay.
You can put it on a presentation mode.
Okay, yes, I shift in the presentation. It's
yes.
Okay?
Okay, yes.
Okay. So, I am very happy to participate in such a webinar because it's a way to spread the knowledge about the good practice and the situation concerning the valorization of organic waste in Italy, mainly for producing biogas. Because I think that we have in our country a lot of good examples that can be also transferred to other countries, to other situations, because the problem of producing energy and in order to have a correct management of wastes is a common problem, not only in Italy, in Europe, but in the whole world. So, we speak about organic waste, and it's clear that we are speaking about a lot of different products. The main categories of organic waste, as you know, range from residues from forest, wood, on wood residues, to waste from agriculture, from breeding, from agro-industrial treatments, and also, and is particularly important for this webinar, from the sewage treatment sludge and the organic fraction of municipal solid waste. This the treatment of this kind of organic waste is suitable not only for produce renewable energy, but also for recovering organic matter for agriculture and improvement of soil fertility. Okay, the first problem that we have to solve when we think to produce bioenergy from waste is to know how many are such waste and where they are. For example, as it concerns with the agricultural wastes, in Italy, some years ago, we carried out a specific survey under the framework of an European project enabling. And as you can see, we saw that in Italy, every year we produce around 25 million tons of both agricultural and agro-industrial residues. And it's obvious that this kind of biomass is of fundamental importance for the production of bioenergy that, as you know, is able to produce heat, electricity, liquid biofuels, or gaseous biofuels like biomethane. Just for a very short consideration, but in Italy, but not only in Italy, bioenergy is the most important renewable energy source. That contribution of bioenergy is almost the same of all the other renewable energy energies in our country. That's because obviously bioenergy, as I said before, is producing heat, electricity, and fuels. Just an example, obviously the waste from agriculture are of different kind. There are woody residues useful for producing energy by combustion, and wet organic wastes able for the treatment by anaerobic digestion. This is an example of a plant in Puglia, in southern Italy, that produce electricity by using only prunes from olive trees of the region. But as I said, the most interesting technology for converting organic waste into bioenergy, in especially agriculture, waste from agriculture, is the anaerobic digestion that we can consider an sustainable and inaccessible source of methane under the form of biogas. Just in order to have an idea about the amount of methane produced by anaerobic digestion, in Italy, we are speaking about something around 2.4 billion cubic meter of methane per year. So it's clear that the sector, the biogas plant sector in Italy is of particular importance, and the number of plants and has grown dramatically in the last decades, and now we have around 2,200 plants, biogas plants in Italy. It's important to note that the most of these plants are plants in the operating in the agricultural and livestock sector, around 1,700 plants. This is an example of one of these plants. It's a small, medium plants, less than 1 megawatt of installed power. But it's important also in such a case to note that the plant is powered by raw materials produced for 60% directly in the farm, and the remaining from a short supply chain. And this is particularly important for the general sustainability of the energy production, but also because the residue of the biogas production, the so-called digestate, is used directly as fertilizer on the fields of the farms. Okay, let's go to the question of municipal waste. In Italy, we now produce something about 30 million tons of waste, of urban waste per year. Now, you can see are less than 10 years ago. That's because during this period, we have reduced the amount of the packaging, and also the disposal of food and other useful products. If you look at the composition of the municipal waste in Italy, you can note that the most important fraction is the organic waste, including also the residues from urban green maintenance. But is a very large fraction of the total. The second is paper, then plastics, and so on. And is of a particular importance to recover as much as possible of this fraction. At the present moment, the mean value of separate collection of waste in Italy is around 60%. About 40% of the total separate collection is organic waste, something more than 7 million tons per year. The most of this collected material is processed in Italy, and there are two main kinds of treatment: the aerobic fermentation, the so-called compost production, the composting, and the anaerobic digestion for the production of biogas. You can see that the most of the plants treating organic waste in Italy are composting plants, followed by integrated anaerobic and aerobic treatment plants and anaerobic digestion. The integrated system is useful because in such a way it's possible to stabilize the digestate in order to remove any kind of pathogenic microorganisms and have a stable products useful for suitable as a fertilizer. This is the evolution of the sector during the last year, and you can note that also if the composting plants are much more than the plants based on anaerobic digestion, the amount of products treated in the plant is almost the same, because the plants treating organic waste by anaerobic digestion are generally larger than composting plants. In any case, anaerobic digestion plants treating organic waste are only a minor fraction of the total of the biogas plant in our country. This is a map showing the location of composting facilities, just the biggest, able to treat more than 1,000 tons per year. You can see that this kind of plants are widespread distributed throughout the whole country. The situation is quite different for the plants producing biogas from organic waste that are mainly located in the central and northern Italy. Obviously, these plants are based on different kind of processes and technologies. The main technology used are the so-called wet technology, that is the same technology as stirred tank used generally for agricultural product or manure. This is an example of a plant treating 33,000 tons of municipal solid waste per year. This is in northern Italy, in Cortona. This is the other kind of technology, another plant based on the so-called biocells. It's a dry technology without adding water, and this is also a plant, medium big plant, able to treat 40,000 tons of municipal waste per year. It's important to note that the process is so well controlled that the final products from anaerobic digestion and composting is a compost, an high quality compost suitable for organic farming, certified for use for organic farming. Okay, till now, the most of biogas produced in Italy was used for the production of renewable electricity. But from some years, we have an increasing interest in the possibility to convert biogas into biomethane. Then to separate the methane from the CO2 and use this methane of biological origin in the same way that the fossil methane. Biomethane has several strengths were known. Is a product flexible. The production is based on widely used and best technology, can be easily stored and distributed from to any by using the existing networks of pipelines for natural gas, and there are a lot of positive experience on biomethane. As a consequence of that, the number of plants has increased dramatically in these last years, and now we have 725 plants operating in Europe. This obviously the most of plants are in Germany, then France and the United Kingdom, Sweden, but also Italy. In that at the end of the last year had 18 plants in operation, is among the countries producing biomethane in Europe. Obviously, biomethane can be produced with several different technologies, chemical, physical, or physical or combined technologies. Just in this and the next table, I have reported the main characteristics of the most important biomethane plants connected to the gas distribution network in Italy. You can see that this is the Montello plants, is a very big plant, able to treat 600,000 tons of organic waste per year. Technologies are quite different, but are both wet technologies or dry technology. It's important also to note that the most used technology for upgrading is the use of membranes. Okay. This is this plants is the only big plants using not municipal organic fraction of municipal solid waste, but agro-industrial and breeding waste, and this in northern Italy near distillery. Okay, so I have finished. Just some data about the biomethane sector in Italy. Now, in a few years, we have reached a production about of 53 million cubic meters of biomethane. We have some different plants, not all connected to the grid. 21 type plants in the end of 2019, and the foreseen production is about 500 million cubic meter per year at the end of the next year. As it concerns the raw materials, you can look at the most important fuel for this kind of plant are is the organic fraction of municipal solid waste, followed by agriculture, agro-industry, and other. Okay, I have finished my presentation. Obviously, I am here waiting for your questions. And so now I thank all of you for your attention and for following my presentation. Thank you very much, and see you during the rest of the seminar, the webinar.
Okay, thank you very much, Dr. Piantelli, for a very interesting presentation. Actually, we learned a lot about the availability of a waste in Italy, the processing, production of biomethane. I may have a question maybe later about how this biomethane is that being injected into the gas network or is being used directly on site. Because last webinar we have it about guarantee of origin certificates, and if there is a kind of guarantee of origin certificates being used, so it can be considered when it's being injected into the gas network. I think it's quite informative. I encourage all of you to send your questions. We start to receive some questions on our chat. I encourage all of you to forward your questions to Dr. Piantelli. Our second presentation will be delivered by Dr. Carla De Corrales. Dr. Carla De Corrales is an international biomass expert with PhD and Marie Curie Research Fellowship on biomass field achieved at IFRF, Netherlands. She has a bachelor in agricultural and technology science at the University Polytechnique de la Marche, Ancona, Italy. She worked as a project manager and technical coordinator of several international projects since 2004. She was also expert of the EU Commission for evaluating projects on biomass fields and researcher at UNIVPM. I think Dr. Carla will explain to us later about what this abbreviation is. For biomass and the bioenergy sector. As a national member of Biomass Consortium, IT Italy BIA, she coordinated the enabling project for valorizing biomass residues in BBFP, which is bio-based products and bioenergy. It's my pleasure and honor to present Dr. Carla. I just pointed before that Dr. Carla, who was responsible in this project in developing our project on biomass, as well as Dr. Carla participated in the development of the sustainable energy strategy of Egypt for the section about bioenergy, where I extracted part of it in my opening speech. Dr. Carla, please go ahead.
Thank you. Thank you very much. And then I try to share my screen. Okay. Can you share?
We can see it, yes. We can, yes, we can.
Okay. And thank you very much. And okay. And my name is Carla De Corrales, and then I say before from Professor Hafez, and then I worked for and support the exploitation of the biomass, and especially the biomass residues and the organic waste in the specific waste to energy. And in this presentation, I would like to give more emphasis and explain the possible option and the benefits deriving from better exploitation of this kind of biomass in the Egypt country, more in particular in the waste to energy. Oops. Okay. And as I said before, the waste to energy represent the challenges to be overcome in the coming years. It is very important to understand which way it is better to use in order to better valorize, to decrease the waste, and at the same time to valorize for the energy purposes. And the 14 reasons I would like to put the attention in the 4 points. The first point is to consider for the strategies in the waste to energy to consider the bottom-up approach because it is very useful. It is very interesting and it is useful to involve the key stakeholders inside of all the chain, taking consideration, for example, the biomass suppliers, the local policy makers, the potential investors, and so on. And another point, the important point that we have to take in mind is to have to know the state of art of the residues and the waste. More in general, we have to know the state of art of the biomass planning, and not only for the quality point of view, but also for the quantitative and the different characterization, the different categories that it is possible to obtain from different sectors, more in particular from agro-zootechnical, agro-industrial sector, rural sector, and the civil sector. And other important things is also to consider the new concept of the valorization of the waste when that it's represent of the zero waste strategy, so the waste hierarchy, where we have to ensure we have to choose the most favorable options that it's represented by the prevention and to reduce the waste, and also to favorite the reuse and the recycling of the waste. And just 14 reasons. And we, in our project, we have tried to valorize the biomass because we think that we can contribute in the waste to energy, giving more benefit, not only for the energy point of view, but we will see the next in the next slide also from environmental, from the social and economical point of view. As explained this morning, we have to reach the energy diversification in the energy plan for the Egypt country. And more in particular, the several targets we have to reach in different times, 15 gigawatts by 2022, reaching to 15.2 gigawatts by 2031. Just in context, we think by exploitation of the different biomass categories, more in particular in the short time, we can focus the attention by valorization of organic fraction of the urban waste, which is possible to cover 1.5% for electricity production in the short time by 2022 at maximum 2025. And by following to reach 2.15, 2.12% of electricity production by 2035, always by exploitation of organic fraction deriving from a urban waste, but also supported by the potential rural biomass. That this is possible to collect and to valorize from a different sector, rural, agro-industrial, and technical sector. And the potential rural biomass, it's so much, But in this moment, we have all taken consideration several points from the national point of view. Even if we have a lot of biomass residues available for the biogas plants or for the bioenergy chains, the market, the biomass market at the national level or the local level are, is not well organized. This one represents one of the principal barrier that to be overcome in the coming years, and the limit the supply, the biomass supply. Biomass supply is one of the key aspects that we have to consider if we want to invest, if we want to implement the bioenergy chains, and we want to reach to produce electricity by using the different renewable energy sources. 14 reasons, I think that's before to use the potential rural biomass, we have also to consider which is the organization, the structure of the farmers, the local farmers. We have also to plan the training for the new professional future, for example, technical manager of the different bioenergy chains, to be able to ensure the successful different bioenergy chains. So as a start point, 14 reasons, I think that if we want to implement without to lose the risk of the bioenergy chains, and more in particular for the biogas, by using the anaerobic digestion biogas technologies, we can start by exploitation and valorization of the organic fraction of the municipality solid waste that in Egypt is well concentrated in the specific governorates, and to monitor and to start organize the rural biomass in the rural area, and to support the first plants with introduction from time to time with the rural biomass. 14 reasons. In this slide, you can see the first analysis of organic fraction of the urban waste supported by the GIS tool and with the maps, and supported with different information about the position of landfill and operating composting plant and not operating composting plants for different governorates. After the first analysis of the potential organic fraction of the organic fraction derived from municipal solid waste, organic biomass, we selected the vocated governorates that are the Cairo and Giza and Alexandria and part of the northern governorates. And also you can see that this selected governorate also has got the operating composting plants. This is very important because this kind of infrastructure could be included in the biogas projects, and reduce the capex, reduce the capital investment, and therefore it's in other words, it means that this is possible to reduce the risk of several projects. And in this slides is the same results, but you can see the list of a selected governorate with priority, because they represent that they have the more biomass organic fraction of municipal solid waste. And also you can just have an idea about the quantity of biofertilizers it is possible to have through the valorization of the digested. The maximum power plant installing for different area, and possible the number of the biogas plant eligible for different governorates. Taking consideration the Prime Minister decree published during 2019, where are highlighted the minimum and maximum power stelling covered by the feed-in tariffs. We also take in consideration the range of the biogas plant eligible power stelling, that is represented by a maximum of 20 megawatts of power stelling and minimum of 5 megawatts power stelling. Even if for some governorate is suggested to consider the size, to reduce the size of the power plants due to the lacking of critical mass, the lacking of the waste. More in particular, in the first group of the governorate, it is possible is suggested to use the organic fraction of the urban waste, and that it is this is possible to take some specific agreement with the waste operator as well as the governorates, and also to choose the selection of the size of the power plant between 20 and 5 megawatts. And followed by another group, another list of the governorates, where it is suggested to reduce the size of the potential biogas plants up to 5 megawatts, and another kind of a list of governorates where it's suggested to integrate the organic fraction of the urban waste with potential rural biomass. When I explain this is better, when we say the rural biomass is not, we don't have to consider a lot, we don't have to consider all kind of biomass residues. We have to, this is better to avoid the linear cellulosic biomass, because this kind of categories of biomass is better to use for other kind of bioenergy projects, for example, CHP system, or used in the co-firing system for industry sector, for example, cement factor. But for the specific biogas plant, we suggest to start the integration of rural biomass represented from manure or slurry or vegetable residues, or byproducts derived from a specific agro-industrial sector. And at the same time, we also considered another important organic fraction derived from urban waste, more in particular, not solid waste, but liquid waste. I mean the sewage sludge derived from wastewater treatment plants. And as you can see in this map, it just is evidence that that we have the promising governorate, for example, Cairo, and Alexandria, where we can start to plan the specific biogas plant. And also in this case, also in this case, we have selected the promising governorate with high priority for this valorization of specific waste, but with by selecting reducing the size of plants from 1 to 5. And for another kind of list of governorate, we suggest maybe to use the sewage sludge not as a single and principal biomass, but maybe integrated with organic fraction of municipal solid waste. Just 14 reasons, and the first analysis of our report, we think in order to to accelerate the investment in the biogas chains, we suggest to integrate the several organic fraction of urban waste, more in particular organic fraction of municipal solid waste and the sewage sludge derived from wastewater treatment. And as you can see, that organic fraction represented the most of important waste. But at the same time, we have to accelerate and where it's possible to ensure the biomass supply for different biogas investments. And also, we have tried to see how many plants we can highlight for virtuous or promising governor rates. You can see in the green the most promising governor rate, and the red, in the color red, where the biogas or bioenergy chains is not considered as a good investment, because the risk of investment is higher if compared with the green governor rates. And more in particular for Cairo, Giza, Alexandria, and Garbia and Dakaria, we can start with the first investment by exploitation in the short time, with exploitation of the organic fraction of urban waste. Sorry? Oh, sorry. And for other kind of governorate, just always close to the north of Egypt, is suggested to integrate the part of organic fraction with the rural biomass. In this table, there is the same concept as I explained before. And after the first distribution and analysis about the potential and distribution of the biomass, we can also we have analyzed the cost benefits related to the biogas chain toward to the exploitation for the waste to energy plant. And in order to ensure the good investments and the sustainable project in the waste to energy, we have also considered the different key points. The first, the different amount of the feed-in tariffs, and we have selected the two kinds of the feed-in tariffs, also taking consideration the Prime Minister decree they published during 2019. And we have also considered the different size of the power plants. In this case, we consider 20 as the range and the maximum and the level, maximum and the minimum of the size of power plant, 20 and 5 megawatts. And we also consider inside of our analysis the capital investment followed by operating cost. And the biomass supply, that is a very key point, and therefore the amount of the tons necessary for the different size of the biogas plants. And also the quality standard is another important point, and the amount and the potential price of the biofertilizers that is possible to obtain by valorization of the digested. And possible is the agreement required from different operator, developer, and the biomass supplier, or the biomass or the waste supplier, and electricity production. That is necessary to have this specific agreement, and also the involvement of the project stakeholders. And as you can see in this conceptual map and the schemes, we have highlighted different options for specific power plants with a different size, and with a combination of the potential nominal price of fertilizers. We consider a 3.75 euro for tons as a nominal price, just to cover the transport cost. But we will discuss later about the importance of to put the minimum cost of the fertilizers as a very small price, and the possible option related to the price, the feed-in tariffs. And just you can see that the best option is to remain with the size of the power plant between 5 and 20. And the best option is represented by the feed-in tariffs close to the 1.40 EGH pound for kilowatt hour produced, of electricity produced. And also to consider at the same time a minimum nominal price or symbolic price of the biofertilizers produced, because just you consider that for each biogas plant, we produce not just for electricity, but we can produce an amount, the huge amount of fertilizers, and it's very important to plan the small revenues coming from different byproducts. If we want to produce electricity, because the biogas technologies is a very good technologies that offer not just electricity production, but also another product that could be the different, especially in agricultural sector, and could open the new opportunity, the new opportunities of increase the revenues, and especially in the local, for the local farmers. In this slide, okay, we also, you can see the different investment and the payback time for a different investment by consider a different option. That you can see, for example, if we want to invest for the medium power plants of biogas power plant of 5 megawatts, with the feed-in tariffs fixed to the 1.40, the discount payback time should be more or less around in the 8-9 years. And but this kind of economical index decrease, and therefore it's mean that the risk of investment increasing if the feed-in tariffs decrease from 1.40 Egyptian pound to 1.04 Egyptian pound. And in other condition of our analysis, if we, the part of fertilizers is not covered by a minimum of price, that it's mean that we have the revenues is covered just for the feed-in tariffs, the investment could increase the risk, and therefore both in the first and in the second option is not suggested to invest in this kind of the project with a specific condition. The condition could be changed, okay, could improve. In this case, you can see that we increase the power reselling, and we select the nominal price for fertilizers, and also to consider the feed-in tariffs as selected both 1.40 or 1.04. The investment is suggested because the risk is lower if compared with other conditions. And also more in particular, you can see that in the first, option, 3.8. The economic condition is very promising with a good discount payback time. This is included between the 4th and 5th years. That this one is a very, very good investment. In other case, okay, we can see that the risk increase if the part of investment is not covered by the cost of the fertilizers. And just for 10 reasons, I think that's when we want to plan the bioenergy chains, when we want to plan the particular projects, we have to consider not only the feed-in tariffs. Yeah, this is very important because it's a key point in order to accelerate the green electricity production. But it's not just the single parameter, the key parameter. We have to consider the other, regarding to the biomass exploitation in bioenergy sector, we have to consider this different parameter. In this case, the cost of the fertilizers. I would like to just add further keynotes or to simplify it, to summarize the keynotes for a potential investor in the biogas sector and more in general in the waste to energy plant. The business model, in specific for the biogas plants, are economical sustainable if supported by the feed-in tariffs is the first point. The fertilizer sale, and just you consider that the 3.75 euro for ton is very, very cheap, is a nominal price. If you consider that the price of fertilizer in Egypt during the last years, it should be 1,500 Egyptian pounds for tons. And then you can see that just for 70.50 Egypt pounds for tons, it was possible to increase the sustainability for the biogas projects. And another important thing is represented by suitable power scaling that should be based on the biomass supply. Is because sometimes I see that the biogas plant, when the biogas plant is not covered by other way the biomass supply, the project is dead. The project is the risk of the project is higher. And another important thing, for a more sustainable projects, the economical condition could be improved by increasing fertilizers price, as I said before. And other important key point is monitoring or check the biomass quality and also the biofertilizers quality if you want to increase the price. And this kind of points could be supported by a huge of technical standards. It is possible to have from international or technical organization or European technical organization, UNIHAN or ISO. And also important things is to have the clear agreement about the supply agreement, both for biomass residues and both for the waste, urban waste, and also for the biofertilizers, and clear power purchase agreements, ensuring the biomass supply. Another important thing is to select the suitable lands where the biomass or the biogas project will be implemented, because it is necessary to have the minimum infrastructure that ensure the transport of the biomass supply as well as the storage of the biomass, and to connect the grids of the electricity produced from biogas plant directly to the grid, or maybe the uses of the potential fertilizers in agricultural sector. As conclusion, we can conclude that, explain that the biogas projects, if compared with other kind of biomass or bioenergy chains, are more sustainable and can contribute giving a huge several benefits from different point of view, from environmental point of view, economical point of view, and social point of view. Because from environmental benefit, just you consider that just by starting to use the organic fraction of municipal solid waste derived from urban waste, we can contribute by 2022 with the first 210 megawatts as electricity by renewable energy sources. And at the same time, this is possible to increase the energy storage in the smart grid energy system, because from the different planning of the bioenergy projects, we can reach the production of the potential biomethane around 600 billions per year. And then this kind of biofuel could be also considered as a storage. Maybe we can compensate the intermittent, the production of electricity if integrated with other renewable energy sources, I mean wind and solar, and to reduce the environmental pollution, and as a start point reaching by 5 million tons of CO2 equivalent per year, and to avoid also the urban waste for a minimum amount of the 15 million tons per year, and contribute to the market supply with the local biofertilizers with a minimum production of 6.5 million tons as a biofertilizers. And just you consider that the fertilizers demand in Egypt during the last year is reached 10 million. That it means with the production of biofertilizers, we can reach 60% of the national demand. And from economical point of view, we can reach the different benefits and to save the government for further subsidies for the traditional fertilizers. And at the same time, to save the fertilizers cost for the local farmer that represent more or less 50% of their cost inside of farm, and improve the revenues of local farmer for new investment by electricity production and by fertilizers production. And that last point, but not least, we created the new jobs with the new with the new future, for example, technicians, operator, in the waste management, and also the manager and the technical operator in the bioenergy plants. And therefore, with a different technical operator that can cover different aspects of the waste to energy chains. And I think that this first presentation, this first introduction about the benefit and the opportunity that the biomass exploitation, more in particular the waste for energy in the short time, could be a useful tool for planning for Egypt country. Thank you very much for your attention. If you have some questions, don't hesitate to.
Thank you very much, Carla.
Thank you. Okay.
Thank you very much, Carla. It's a very informative and very excellent work about potential for municipality solid waste. Point about importance for having pricing for fertilizers produced, which could make the project economically sustainable or attractive, which is, I believe, is missing from the Prime Minister decree, which is only issued a feed-in tariff for electricity products, but this is a multiple products facility. Also, it sent a very threatening message to fertilizer producers that as this fertilizer or these biomass plants will operate, we could cover 60% of our fertilizers needs, which will come from a biofertilizer, which is quite valuable, as many of businesses now is towards bioagriculture products. Yeah. So biofertilizers is very much will help in advancing the agriculture business in Egypt. Also, you pointed that the importance of biomass or biogas plants is not just 230 megawatt, which could produce from this, but it's distributed, it's dispatchable, it could provide a storage in the system. So it's more valuable compared just being looked like, as you mentioned, 1.5% or 2.1% of the total renewable energy. It's more valuable as it's provide a kind of stability to the grid as a dispatchable and potential for energy storage. I think, unfortunately, we don't have Dr. Farra with us because the coming presentation is basically will be a kind of a point of view of developers regarding the regulation, procedures, implementation of the program for waste to energy, which is coming from one of our knowledgeable investors and developer for this plant. Sure, Dr. Farra, if he was available, he could clarify many points, as he was a key person in designing the feed-in tariff program, as well as providing support to the WEMRA, which is basically the program leader. Although, as Carla pointed out, I appreciate if some of our participants could mute their microphone. I mean that, as Carla mentioned, that this is a multi-stakeholder sector, which is make it complicated. But as now, WEMRA is taking a lead with support of many stakeholders, like Egypt ERA for electricity contracts, governed rates for sure. As Carla pointed out, there is a full package of contracts, which is the governed rate are responsible for, so they are also key play. I have the pleasure to introduce Dr. Hatem El-Gamal. Dr. Gamal has a BSc degree in pharmacy and MBA in marketing and management. He is an entrepreneur who established the waste to energy. Some of our participants could mute their microphone. Yes, Dr. Hatem, I think if you could mute your microphone temporarily till we could switch it to the presentation. Dr. Hatem El-Gamal established the waste to energy market in Egypt. He was one of the pioneers. I remember we met back in 2009, 2010, when he was talking about waste to energy, when I was in the regulatory agency. He is a chairman and a CEO of Empower NRE group, who ensures and participated in several roles in the sector and developed high quality fertilizers out of organic waste. Please, the floor is yours.
Hello, good morning, everybody. Can you hear me well?
Yes.
Because unfortunately, I had a technical problem, and I'm now joining you with my mobile from my laptop. So, okay. At the beginning, it's an honor for me to join this meeting because as
I appreciate Dr. Gamal, if you could speak louder, a little bit louder.
Okay. Good afternoon, everybody. Joining us from everywhere in the world. I think this will be we had several presentations about the technology worldwide, especially in Europe, and I think the transfer of this technology to Egypt was not something easy at the beginning, especially with several challenges that we had to face. As Dr. Hafez said, we met in 2011 to have several discussions about how to develop this sector. Actually, as Empower, we started in 2014, our first investment, and we built several projects with a total capacity of 4.5 megawatts currently in Egypt. And we have an expansion plan of building 17 plants across Egypt. Currently, these projects were distributed across Egypt. Once we started the projects and we started to build, we had an approval for the avoided cost of the electricity at which the government will pay us the current cost of the energy that they are generating from heavy oils, mazot especially, and then we will be paid this way. And at the beginning, at the previous pricing and the exchange rate, that was relatively attractive. And we started our first project. And then an official decree was issued with a lower feed-in tariff than the one that, of avoided cost. That made a very big challenge for us, at which we had to develop a very specific fertilizer that generated, and as I see that you currently in Italy, you have developed such a fertilizer. This fertilizer will add a lot to the actually سامعني؟
Yes, Dr. Gamal, please go ahead, but you have a little bit noise, a background noise. If it's possible, you can go for some place where noise is less.
Okay. So we had to develop a specific fertilizer out of this project. This fertilizer actually helped us to overcome the financial challenges that we were facing due to the low feed-in tariff that currently issued. And another aspect about the feed-in tariff what issued at that time is actually the point of it's not tied to the exchange rate or the US dollars. So that had a very big impact on our model, at which we were not able to finance our projects, and at the same time, we did not have any stable revenue streams. And after all of this, we were able to finalize our model, at which currently our model is mainly based on fertilizer. We are talking about 85% of it as fertilizer, and only 15% of the revenue comes from the electricity. But the main challenge, as mentioned before, is that the total market of the organic farming in Egypt only represents 200,000 acres distributed across Egypt, and who are following the official rules of organic farming only represents 40,000 acres across Egypt. This gives a very small niche market. We are currently having good business in it, out of it, but it cannot absorb any further expansions. So the only proper solution that could cover this is either by having a proper pricing and proper engagement from the Ministry of Agriculture in helping us in the distribution of this product, because currently Egypt is going in conventional farming, not organic farming. We have in Egypt currently, after all the updates, about 10 million acres, and only out of them 200,000 acres, as I mentioned before, is going for organic. The agriculture waste solution will only be based on organic farming plus organic product, fertilizer plus electricity. But when we are talking about an MSW or sewage sludge, we have several challenges. The organic product fertilizer sold out of the MSW it's not accepted to be used by the farmers, and at the same time the sludge, at which they are representing a big part of the waste available in Egypt. Adding to this, you will have another challenge at which that the sludge currently is being sold in Egypt. So any financial model that you're going to have sludge, instead of having a gate fee, you have to purchase this waste. So when you see it from a helicopter view, we had our solution, but at the end of the day, you have a small market for it. You don't have a big market to expand. But when you take it from another level, the level at which the government has to change the feed-in tariff so this market will grow, and you have a lot of players, and at the same time having either an inflation rate or to be tied with the exchange rate, at which to be able to access international finance, at which it will have better payment terms. As currently, we're taking relatively a higher interest rate and a shorter tenor for our financing our projects. And access to finance for such projects is very important, because normally this is financed 85% debt with at least a 10 to 15 years tenor, not 5 and 6 years tenor. So having an access to finance as a second challenge is an available challenge that we should be tackled and by either introducing Ministry of Agriculture to be able as an off-taker through its distribution channels for the fertilizers, or changing the structure of the feed-in tariff, the 41 decree in 2019, so we can have this sector to grow. And another third challenge, which is one of the most important challenges that we had to go through for the legal structure and the legislations, at which we have to go through 32 committees, securing approvals from 11 ministers and authorities in Egypt, so we can finalize all permits and licenses required to be able to build our plant. With our experience and our teams, it takes us now 18 months of approvals, documentations. First time it took us 3 years. This is a challenge. We have to have templates for contracts, legal documents, and which laws that were going to be used for every single place in Egypt, because every single time we have to go through different modules and different approvals to secure different laws to secure the land permit, for example, the access for the waste, for example. And this challenge is not an easy challenge, because it's totally situational. Every single time you have to change the situation according to the challenge that you're facing. Okay, so, and finally, who will pay us our money in terms of electricity? And this is really a big question mark. because currently the proposed way and the electricity payment for the waste to energy, according to the newest decree, will not be the distribution companies. It's going to be the government, the governorates and the governors themselves. So now we are taking money from authorities that don't have a regular cash flow. So this is very big risk for us, that there will be very big challenge in collecting our money. Why? Because simply the Ministry of Electricity should, or the distribution company should pay the governorates, and the governorates themselves will pay us back our money. But as the normal practice is that the governorates owes Ministry of Electricity more money. So what is going to happen is always a delay in payment. Another thing, in regards for the other part of the tariff, as you know, the tariff consists of two parts: 103 piastres paid by the Ministry of Electricity, and 37 piastres will be paid by the governorate itself by collecting the waste collection fees. This means that the other part, which is going to be collected by the governorate, they don't have currently any collection technique for it. So I have another risk about the other part of this tariff that I don't think that is going to be solved easily, which is the 37 piastres that's going to be paid by the governorates themselves, So having two parts of our tariff, part by the Ministry of Electricity, which is most probably will be deducted from the money that the governorates owes the distribution company, and the other part with no collection module. So there is another dimension and another risk that having the contract of the tariff from the governorates, this is a very big question mark for us and for all the investors in the market. This agreement should be done between the distribution company or the electricity transmission companies with the private sector. So to summarize the main four challenges, we have at the beginning the fertilizer challenge, which is the biggest challenge, as currently we don't have it because we are the only player in the market. Once a lot of players started, there will be a big challenge because we are using conventional farming. It resists more than 98% of the market. The second part is the permits and required approvals for our projects, which is not an easy challenge. The third challenge is access to finance, at which we have to make sure that if we need this sector to grow, to have several structural changes in our offtake agreements by the government or by Ministry of Agriculture or Ministry of Electricity, as I said before, so we can access international financing, because this will be more lucrative, let's say this way. And the final one, as we said, is who are going to pay us our money, and who is the part of who will pay us the contract, who it will be with which entity, so that even it will be secured. Because as per the current status, there is no gate fee, and we are procuring waste at the same time. Those are the main challenges, and I think I illustrated some solution for them. And these solutions are the only way to have this market to grow. Because in Egypt currently, we are having about more than 2 million acres are currently is being built and reclaimed. These sectors are currently using diesel engines to generate and to secure their electricity, and they need fertilizers. For me, this is the biggest sector. This is the most attractive sector, because the current cost of electricity currently for these sectors is 3 Egyptian pounds per kilowatt. And this will be a very good off-grid solution for them. I'm reducing for them the cost of electricity, and at the same time, I'm giving them good quality agriculture. Having the experience of the Italy as a composting model, because I was exposed 2 weeks ago to a detailed model of a biogas plant going to be built soon in Italy. The high quality compost represents about 40-something% up to 50% of its revenue stream. But in Egypt, as I said, the one that we succeeded to do, it only represents electricity only 15%. So structuring either increasing the revenue stream by the electricity, or having a good offtake agreement by the government for the fertilizer and distributing it with its very well structured distribution channels of agricultural companies, as this is a current practice, this will help the sector to grow. Especially, it could replace up to 50% of the normal fertilizers added by the farmer and their normal practice. And currently in Egypt, the agricultural sector is one of the fastest growing sectors in Egypt. So this is the summary of the challenges. I wish I was able to share that presentation, but unfortunately, I had a connection problem, and I'm ready for questions.
Okay, thank you very much, Dr. Hatem, for a very enlightening speech regarding the challenges faces. I believe after that we could rename our webinar not waste to energy, but waste to fertilizer. Because as you mentioned that 85% of the revenue streams come from fertilizers and just 15% come from the energy. And I believe this is a very important missing point in the Prime Minister decree, which is look only from the energy point of view. But I believe, as Carla pointed out, the report developed by our project is basically highlighted very much that projects will be unsustainable if fertilizer has not been purchased and being priced. So this is a key point. Also, you raised the point of access to finance and exchange rate. I believe the decree include a kind of a mechanism for change in pricing based on change in exchange rate with a certain margin, but it seems it needs to be revisited based on the application. For permits, sure, the experience gained in renewable energy projects by NEREA in enabling these permits on behalf of the developers could help. Sure, the projects for waste is more complicated as number of stakeholders are much higher compared to projects like wind and solar. Yet, I think the gain experience could be used in this aspect. We have received several questions. We have just 10 minutes. Dr. Hatem raised his hand. Yes, please, Dr. Hatem, go ahead.
Actually, you had mentioned this, and I tried it several times about the regulation, the permits. When we're talking about solar or wind as a solution, you don't have any stakeholders in comparison to waste. The main challenge of waste is that there is no owner of the waste in Egypt. You have to talk with all the authorities I had to go spoken about. Who owns and regulates the waste? There's no authority so far. Even itself, the waste management new entity built, WEMRA, I think it's called in the Ministry of Environment. It's advisor. It's advisor. There is no entity. There's several stakeholders that you have to deal with. And the other point I highlighted in regards for the fertilizers is that the market is very small for organic farming in Egypt. It's only 2% of the market. 98% is conventional farming. Yes, the 2% for one company or 2 or 3 companies could be a good business. But when we're talking about the whole market and whole waste to energy, it's totally different.
Yes, I think this has led us to a question raised by Dr. Subki about what kind of incentives. Actually, there is some incentives which is given in the Prime Minister decree, yet, as you mentioned, that we need to expand the fertilizer, the biofertilizer market more. So might be this is through a kind of regulation for agriculture or organic agriculture, which could offer some kind of incentives for farmers to switch to. But still, by the end, we need a committed partner who purchase this and then have within the government itself a methodology in order to promote this biofertilizer. So we need to build this system. We have a question about, I think this might be forward to Carla, about is that looking at distributed kind of generation of biogas, like the Chinese and Indian approach, where in every village there is, or every home there is a distributed, which is primarily using it for cooking purposes more than being used for electricity generation. Is that could be a kind of a lower cost application, or going for sophisticated plans for electricity production with much higher risk to the project? Which approach, or could they live together, or how we could proceed? Carla.
Okay. From my point of view, yes, I see the different during the analysis, and I also monitor the different biogas technologies came from China or India as well. And I also analyzed that, for example, in Niger, there is beautiful, very excellent project founded by UNDP, the United Nations Development Program, for biogas, small biogas plants to be implemented in the rural areas, very, very small plants, just for cooking uses, and produce the small quantity of biogas for household uses, but not for electricity. And from my point of view, okay, is it possible to also to consider the technologies less sophisticated than the European biogas plants, but we consider that when we want to produce the biogas is a fuel. And then if we want to produce in the we want to ensure the good quantity, we want to ensure and electricity production in constant way. We also to have the good technologies with all, and we have to ensure the health, and we have to reduce the losses of the fuel, especially of the biomethane. And okay, it is possible to reduce the cost of technologies, but I didn't see the Indian technologies for the biogas plants in the small area and the small power plant for production of electricity. And also another important things, and especially if we want to implement the biogas plants in the rural area, is also to prevent to start with the training of farmer, because it's not easy to think, okay, we put the technologies and the technologies directly produce the electricity. I don't have think the biomass. No, it's not. It's necessary to have the preparation. We have to think of the training, because more in general, the biomass plant require more effort if compared with other technologies. And then we have to understand the quality, the quantity of biomass, and we have to understand, for example, which kind of biomass we don't use for production of the biogas plant and other consideration. So even if we want to reduce the size of technologies, not just for 1 megawatt, but also for 0.2 megawatts of power installing.
Okay, we have a question to Dr. Piantelli about the biomethane. Is that using biogas as a raw biogas or converted to biomethane, it will produce CO2 due to separation? Is that biomethane will be injected into the grid, or it will benefit in using smaller unit for power production? So what's the economics of switching biogas to biomethane?
Okay, but the switch from biogas to biomethane is mainly justified by the obligation to introduce renewable energy in the transport sector. The main foreseen utilization for biomethane in Italy is in transport. The plan for 2030 in Italy is to produce as much biomethane as is the total methane consumption for buses and private cars in our country. The question, the most interesting question is that if I have biogas and want to produce biomethane, I have to separate, obviously, CO2 from methane. But it will be possible to convert also, to transform CO2 into further amount of methane by using hydrogen produced, for example, from excess electricity from other renewable energy source. Is the so-called power to gas way. And in our country, but not only in our country, there is an increasing interest. Because if I can convert also CO2 to other methane, I can use the whole, I can valorize the whole energy content of the biomass and can also avoid problems linked to the peaks of electricity production, for example, from photovoltaics on wind energy or similar.
I think Dr. Piantelli has raised a very important point about that feasibility, not just convert to electricity, but convert to a biomethane, which could be used in the transportation sector, keeping in mind the current program, national program in Egypt for converting transportation or some cars to natural gas. So it could be blended. Specifically, we are tapping to another more rewarding market from maybe just electricity, specifically if we consider a green methane, which could be used. And I think I could link this with our previous webinar about guarantee of origin certificate. So this if this biomethane will have its guarantee of origin certificates, and there might be some kind of new regulation regarding guarantee or green transportation. I think this could be another market for waste to biomethane. So we now today we learned that we talk about biofertilizer, biomethane, and electricity. Dr. Soki is quite active in questioning, actually is asking, is Egypt era could work for rechanging or reformatting Prime Minister decree regarding that, as Dr. El Gamal mentioned, payment should be directly from distribution company to the developer and not go the other way, where we turn around developer supply electricity to distribution company pay government rate, and government rate pay back the developer. I think this might be an area where Egypt era should work on to facilitate specifically electricity or distribution company are responsible who collects the garbage fees. So basically they have the money already, so they have a guarantee from the or the resource for payment for this electricity which is being supplied. Dr. Hatem, please go ahead. Please unmute your mic.
Actually, what I want to add about biomethane, there is a very important point, is that we actually tried this several times as communication, as another part instead of electricity. But actually, as you know, currently Egypt is going to be a gas hub for the region, as in terms of production for our new fields, and at the same time collecting and exporting natural gas from several sources. This is relatively a challenge for the biomethane, because currently we have abundance of it and we are exporting the excess actually. And once we started with e-gas of the communication, they gave us a very low tariff at which they told us that this is the minimum. This is in compared to the pricing of the gas that we're generating, and why the government is going to pay more. But the only solution available for the biomethane will be in the rural areas, and especially the new Hayat Karima project is adopted by the government, at which we will build all the infrastructure required for the small villages, etc., etc. And currently they are using LPGs as source of energy, and the cost of the 1 million BTUs in the LPGs is more than double the cost of LPGs, and more than double than natural gas. So the biomethane solution, from my point of view, will be only useful in rural areas and off-grid places. This is how I can see it.
Hatem, yes, this is Dr. Hatem. Still the perspective that we don't value biomethane as a clean fuel or zero carbon emission fuel. We still evaluate it like natural gas is just a fuel, just a source of energy. But if we valued or look at it as a zero emission, it will be different, specifically in the transportation sector. As Dr. Piantelli mentioned, this is the main market because this sector will switch to electricity. It's we don't need natural gas for it. If we kept supply natural gas, it's still an emitting fuel. Switching to electricity and electricity supply from solar or wind will totally take over. So if we introduce biomethane to this market, it could present an alternative of zero emission or sustainable transportation. So we need to have a long vision forward and not just evaluate based on what we have it today. Exactly the point raised usually by electricity companies about why we need to invest in renewable energy while we have a surplus. you need to invest in renewable energy because it's cheaper. So, and according to the estimate in the strategy, regardless the resources you mentioned, we will get an energy deficit by 2040. We need also from security point of security of supply point of view. Yes. We have question to Carla also regarding job creation. You mentioned one of the conclusions. You mentioned that important for job creation. We could evaluate job creation. How many jobs could be created based on international experience? Maybe also Dr. Piantelli maybe later comment on this in Italy. So Dr. Carla, for job creation, do you have certain numbers or reference for how many jobs could be created based on certain amount of ton or whatever?
Okay, yes, and I see from several practical experience that, for example, for the power is selling of biogas plants more or less 1 megawatts for electricity, and it is possible to improve depending on the situation, if installed by using the rural biomass or urbanic biomass. But more or less is a five technical operator for plants, but also is necessary to consider the indirect jobs that we increase because it's not just two operator that's monitoring the power plants, but operators that's working for the biomass supply every day, and depending on the size of power plants, and increase the jobs for the technical operator that's working for monitoring the quality of the biomass. You think, for example, the chemist in the laboratory that every month should be analyzed the different sample. And for example, the biomass laboratory can increase the operator, the chemist, by giving the contribution, the services for different plants. And maybe we can organize the labs with 5, 10 other technicians. And other kind of operator is a manager, the manager of the power plants. And maybe if we want to make summary of the job creation, I can think 15, 20 operator for by energy chains, more or less, depending. If we consider the waste, urban waste, the job creation increase because you have to collect and you have to manage the urban waste, the collection, separation, recycling every day. That we have to create the operating group.
Okay, Dr. Piantelli, is there a number in Italy how much job created in this business for waste to energy?
Yes, as said my friend Carla, the situation is different if we consider the agricultural supply chain or the production of biogas or biomethane from municipal solid waste. But in any case, there are several different estimations based on the installed power. Is a generic evaluation, but generally the mean value ranges from 8 to 12 or 15 employees per megawatt of installed power. It depends. For example, the urban waste chain requires many people for the separate collecting of the waste, and there are also other possibilities to create a job with the control and the management of the different plants, and also the quality control of the fertilizer. Because as I said before, the production of fertilizer is a key issue referred to the economics of the production chains. So it would be possible that the real number of created jobs is greater than the number that Carla or I are saying now.
It is good. Actually, the answer is meaning that the job numbers are high quality job, high qualified job. Basically, when you talk about quality control, you're talking about plant operation. So it means that we need a very strong capacity building program. It's not a job opportunities for unqualified operator. No. It's a quality. It's
more for qualified
operator. Yeah. I think at this point, if one of our presenters would like to add something.
No, just as I said before, the quality operator, agronomist, and engineer and chemist. And it's necessary to think the training also for the local farmer. This is very important. Yeah.
Yes, very, very good. I think one of the, in one speech in the commencement graduation, actually the president of the university, our university mentions that if you have come with questions more when you being graduated more than the question when you entered the university, so we have succeeded in our job. I think our webinar today raised more questions than the answers we have. We already have very good answers, but it raised a lot of questions about the program here in Egypt and challenges, and pointed a lot of challenges. And I think this is a very good success through having this debate about and exposed to the international experience in Italy, the excellent report developed by Carla, which is emphasized on many important points. I think this is set a kind of a roadmap of what we should do to enhance and improve our program for waste to energy, waste to fertilizers, waste to biomass, how we could create a market in different, how we could enhance the Prime Minister decree. And I think this is a learning curve, and the good point that it has started, but we're looking forward to have much better our enhanced approach to take into consideration or address many points which has been raised by also Dr. Gamal in his comment on the challenges. Thank you very much for your participation. Unfortunately, we couldn't respond to all questions, but we took a long of your time. And it shows how this topic is very much important and need much further and not just one webinar. Thank you very much, and looking forward to see you in our next webinar, which will be on sectors integration. So as usually the TV anchors say, please keep tuned to our program of webinar. Thank you very much, and looking forward to see you in our next webinar. Bye-bye. And for sure, thank you for our presenters, for my colleague Marion and May, who without them, we couldn't develop this webinar. Thank you all, and see you in our next webinar. Bye-bye.
Thank you very much.
Thank you.
Thank you. Bye.
Bye.